Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present my final year project 2 for session 2021 and 2022. First, I would like to introduce myself. My name is Mohd Afiq bin Aziz. My supervisor's name is IR Haji Razali bin Hassan. My first panel is Dr. Muhammad Hazri bin Muhammad Rusli, and my second panel is Encik Saiful Bahari. So my final year project title is Design Food Retort Chamber. Presentation agenda for today is introduction about the project, project methodology, results and discussion of the project, and the conclusion and recommendation of the project. Before we go to the project background, I will tell you about the problem statement of this project. Food sterilization or food retort is a process that are needed to extend the food shelf life. It is a process where it kills bacteria, then the bacteria will not spoil the food faster than it should be. But there are many types of retort chamber in the market, but most of it come in a small size, so it affects in the retort volume per time. Thus, the production output also can be low and slow. The objective of this project is to redesign the food retort chamber, which will have a bigger volume capacity and a better processing time by increasing the loading time. Second is to analyze the suitable design parameter of the retort chamber in terms of thickness and by selecting the best suitable material for the food retort chamber. The project background of this project is that food sterilization already started in the 19th century. Back in the days, food are sealed in a can and heated to preserve the food. Extending the shelf life of a food is important to prevent food shortage. Nowadays, we use a retort chamber to preserve the food and extend the shelf life of the food. But there are many types of retort chamber in the market. But however, not all of the retort chamber are compatible with the food seal container. But in this project, we will use a steam air retort chamber to carry out. Next, I will tell you about the methodology of this project. Since this project is about design process are mainly used to carry out this project. So first, we need to decide the product design specification of the food retort chamber that we want to construct in the CAD modeling. And as you can see in the table here, there are several characteristics which has been established in order to create the 3D modeling of the food retort chamber using SolidWorks 2018. These characteristics are gained from the literature study. After the product design specification has been established, several conceptual designs are able to generate from the literature study. As you can see here, there are two conceptual designs, which is design 1 with a vertical retort, design 2 is a horizontal retort. And as you can see in design 3 here, this idea is generated from a pilot retort. With those conceptual designs are established, we need to evaluate the design by using a pure chart. A pure chart consists of several criteria in order to select the best design for food retort chamber. The criteria are as follows: sterilization volume, packaging compatibility, processing time, and handling system. From this picture, which we can see, design number 2 is the best design for food retort chamber, which is a horizontal design. The next methodology is a theoretical calculation. This calculation will help design the food retort chamber. There are two calculations involved, which are food sterilizing cylinder and the wall thickness of the cylinder. This project also will be conducted 3D or CAD modeling using SolidWorks 2018. Finite element analysis also will be conducted in order to select the best material for the food retort chamber. Next, we move to results and discussion. From the design process shown earlier, this is the isometric view of the CAD modeling of the food retort chamber. The volume retort capacity and wall thickness of the food retort chamber can be calculated using the formula earlier. As we can see, the volume of the food retort chamber is equal to 2.8 meter cube, while the minimum thickness for food retort chamber is equal to 6 mm. For the next result and discussion, finite element analysis is conducted on the food retort chamber. It is conducted on the food retort chamber in order to select the best material for the food retort chamber. In the table, as you can see on the slide, there are 3 shortlisted materials to be selected as the material for the retort chamber. The materials are cast iron, cast alloy steel, stainless steel ferritic, and aluminum 1060 alloys. In the finite element analysis simulation, the analysis are conducted onto 3 main parts of the retort chamber, which is the heating cylinder, the base, and the door cover of the food retort chamber. As you can see here, the heating cylinder are applied to 350 kPa inside of it, and we can see the highest stress exerted from the von Mises stress is 5 GPa. The lowest stress is 165.1 of kPa. For the door cover, 350 kPa pressure are applied of the inside part of the door cover, while the upper part of the door cover are applied with the weight of the door cover itself, which equal to 981 Newton. So as we can see from the von Mises stress result, the highest stress exerted is 27.99 gigapascal and the lowest is 69.31 kilopascal. Base of the food retort chamber, the force exerted on the base is equal to the weight of the food retort chamber itself, which is equal to 21,582 Newton. As we can see from the von Mises stress here, the highest stress recorded at 3.187 megapascal and the lowest stress is recorded at 0.6126 kilopascal. So that means that this base can support the weight of the whole of the food retort chamber. Conclusion of this project, the food retort chamber has been developed with a better volume capacity. So the calculation analysis also has been conducted in order to determine the suitable design parameter, which include thickness, retort volume, and material to choose for. The final product provides a bigger capacity of retorting at a time, and with its horizontal shape retort, it also helps to improve the processing time in terms of loading and unloading the load much faster by implementing automation system or operated by little numbers of personnel. And the best suitable material also selected from the finite element analysis, which is stainless steel ferrite. So lastly, the SolidWorks 2018 has been used effectively to design this food retort chamber. The recommendation of the project: to increase the retort processing time, it is recommended to use agitating or shaka retort. These kinds of retort improve the retort processing time by shortening the come-up time, which is the venting for heat to achieve to 121 degrees Celsius by a significant margin, which is much faster than the static retort. Furthermore, stainless steel ferrite is not the only material suitable for the food retort chamber. Another type of stainless steel, which is a 300 series steel, also can be a good consideration for the food retort chamber. And that is the end of my presentation for my final year project 2. Thank you very much for your time. You can contact me with the phone number or emails as shows below. Thank you very much. Assalamualaikum.